Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. Uh, Today we will discuss about chapter 4, sinusoidal steady state analysis. Okay, our subtopic basically is star delta and delta star transformation for circuit analysis. So learning outcome, this is our learning outcome. Okay, so at the end of this topic, you should be able to uh, convert, okay, delta circuit into a star circuit. So what is delta, what is star? Okay, I will show it after this. Okay, kita akan bincang berkenaan dengan star circuit and delta circuit, and then how to convert from star circuit to delta circuit. And number 3, how to solve a complex circuit using star delta transformation, okay, together with the voltage divider and current divider rules or any circuit rules such as Ohm's law, Kirchhoff voltage law, Kirchhoff current law. Okay, so this is the main content of this topic, which is star delta transformation and delta star transformation. Okay, for the introduction, okay, in some circuit we cannot apply voltage divider or current divider or any theorem because of the geometry of the circuit, because of the complexity of the circuit arrangement. Okay, in some cases we may be able to transform the circuit in such a way so that after the transformation we can finally apply the voltage or the current divider or Ohm's law, KVL and KCL rules to solve the circuit. Okay, basically this is the concept of transformation. Okay, first of all, okay, mula-mula kita tengok what is the star. Okay, this is the star. Let's say we have a impedance ZY and Z1, Z2 and Z3. Okay, Z1. Okay, let's say we have a lighter. Okay, this is a Z1, Z2 and Z3. This one we call it a Y. Okay, it looks like a Y. Y. This one we call it a Y connection. Y connection circuit. And this one we have a ZA, ZB and ZC. Okay, it looks like a delta. ZA, B and C. Sama macam delta. So this one we call it a delta connection circuit. So the question is, let's say we have a Y. Okay, try to imagine we have a Y circuit. We have this circuit. Okay, Z1, Z2 and Z3. So how to convert to delta? How to convert? Okay, we would like to convert from Z1, Z2, Z3 to ZA, ZB and ZC. Okay, how to convert? Okay, this is the formula how to convert from Y to delta. Okay, let's say we have a Y, Z1, Z2 and Z3. So how to determine ZA? ZA equal to Z1, Z2 plus Z2, Z3 plus Z3, Z1 divided by Z1. So untuk memudahkan kamu ingat, okay, ZA equal to Z1 times Z2 plus Z2 times Z3 plus Z3 times Z1. Okay, sekeliling ni yang kita darab, and then divided by opposite. What is the opposite? Z1. Okay, similarly to ZB, ZB equal to Z1 times Z2, Z2 plus Z2 times Z3 plus Z3 times Z1 divided by Z2. Okay, ZB divided by Z2 because Z2 is the opposite, and ZC divided by Z3. This is the opposite. Yang ke atas ni sama. Okay, that's the way how to convert from Y to delta. Okay, next. How to convert from delta? Let's say we have a delta given ZA, ZB and ZC, and then you need to find Z1, Z2 and Z3. Okay, so we can use this equation. Okay, Z1, for example, how to determine Z1? Equal to ZB times ZC divided by ZA plus ZB plus ZC. Okay, if you want to determine Z1, okay, kita buat hasil darab sebelah ni kalau nak mudah ingat. kita darab yang sebelah dia. Okay, Z1 yang sebelah dia adalah ZB dengan ZC, so ZB darab ZC divided by summation of ZA, B and C. That's the way lah how to remember this formula. Okay, number 2, we want to calculate Z2. Okay, how to determine Z2? Okay, yang sebelah dia adalah ZA times ZC divided by ZA plus ZB and ZC. ZA times ZC or ZC times ZA lah. Similarly to Z3, how to determine Z3 given ZA, B and C, ZA times ZB, ZA times ZB divided by ZA plus ZB and plus ZC. Okay, so that's the formula lah. Okay, for example, how to apply this formula? Okay, let's say we're given circuit in this. Okay, find the current. Okay, find the current I in the following circuit. Okay, let's say you have a circuit. So how to determine current? Basically, in order to determine current, you need to find the Z total. Okay, seen from the source. Is it correct? You need to determine Z total. The question is how to determine Z total, because you have this one, you have a star delta connection. Okay, this one you have a delta. Okay, delta. This look like delta. Can you imagine delta? Dia macam ni ya. Okay, hampir sama sebenarnya. Okay, this node A, node B, node A, and this is node C, delta. So you cannot solve. It's difficult to determine the Z total or Z equivalent. So what you need to do, you can transform to Y. Okay, you can transform to Y. This one become Z A. Okay, ZA, let's say ZAN, this is N point lah. This is the point of connection between three impedance. We call it N. Okay, ZAN, ZBN, and then ZCN. Okay, we have ZAN, ZBN, and ZCN. ZAN, ZBN, and ZCN in Y connected circuit Y. This is a Y. So the question is how to determine ZAN. Okay, ZAN equal to yang sebelah dia darab bahagi dengan total. Okay, sebelah dia J4 times 2 minus J4 divided by total. Okay, Z, let's say this one, let's say Z1. Let's say this one Z1, Z2, and Z3. Okay, ZAN. ZBN from B to this common point. So yang sebelah dia adalah J4 darab dengan J8 divided by total. Total lah. This total equal to 10. Okay. Similarly to ZCN. ZCN minus J4 or 8 ohms times minus J4 divided by total. Total equal to 10. Okay. So you will get ZAN, ZBN, and ZCN. So kalau kamu lihat circuit ni, so lebih mudah untuk kamu solve dia punya total impedance. Yang ni series, okay, yang ni series and parallel with this one, and then series with this one. So you can determine total Z, and then you can determine current. Okay. Sorry, this is Z. This is impedance. This is impedance Z. Okay. So then you can determine total impedance, which is 12 in series with ZAN, and then plus parallel this one, parallel with this one. Okay, then you can solve for Z, and then you can determine current, because current equal to V divided by total Z, and then you will get this current. Okay. Okay. That's the application of delta Y transformation. Okay. So you can try this exercise, exercise 1. Okay. Calculate current in the circuit below. Okay, in this circuit, you need to calculate current. Okay, what is I? Okay, in order to calculate current, you need to determine Z total, Z seen from the source. Okay, yang ni tak boleh kan nak determine Z. So, how to solve this circuit? Okay, this is delta. Can you imagine this is a delta, or this one also delta? Okay, you can choose whether you want to convert this circuit to Y connection, or you can convert this one to the Y. Let's say we try to convert this one to Y. Okay, this is, let's say, ZA. Okay, ZA. Okay, let's say this one is ZB, for example. Y connection circuit, ZB. Okay, ZB. And then this one ZC. Okay. You can use your notation Z1, Z2, or Z3, is up to you. Then you determine this Z, and then you convert from delta to Y. Then you can solve this circuit. Nampak tak? Yang ni series, and then this one series, these two branch parallel, and then series. Then you can determine total Z. From the Z you can determine current. Okay, boleh try yang ni, boleh cuba yang ni, how to determine. First you need to convert from delta to Y, and then you can solve the circuit, find the total Z. From the total Z you can determine current. Okay, similarly to exercise number 2. Okay, try to find Z total. Can you find the total Z? This kind of circuit we need transformation from delta to Y. From delta to Y. Can you try? Okay, this one you convert to Y, and then you solve for Z total. Okay, this is the final answer. Okay, I think that's all for delta Y transformation. This is some application of delta Y transformation for solving the complex circuit. Okay, itu saja untuk hari ini. Okay, Assalamualaikum warahmatullahi wabarakatuh.